So now we're going to do example 3, and all of these examples on this page of notes are non-calculators. I'm going to write that at the top of this page, that this is a non-calculator page. Right, and we're going to be looking at functions. F of x equals x squared plus 3, and g of x equals the quantity x plus 3 squared. We're asked to evaluate each function. So let's start off. Part A asks us to evaluate f at 5. So let's go ahead and do that. So f at 5, I'm going to put a 5 in for x and square it and add 3. The important thing to remember here is order of operations. We have to do exponents before we do the addition. So we get 25 plus 3, and my final answer is 28. All right, then let's go ahead and look at g of 5. And I would like for you to do this one on your own, and then you'll be able to put in your answer for what you get. All right, and let's check and see if you got that right. We're going to say 5 plus 3 squared. Now this is different than the previous one, because on this one we're going to add the 5 and the 3 first to get 8, because that's in parentheses, and then we'll square it, and so our answer is 64. Okay, let's go on to part B. And part B asks us, does f at 2 plus 5 equal f at 2 plus f at 5? Anytime you're asked if two sides of an equation are equal, you have to solve each side of the equation separately. So let's start by doing f at 2 plus 5. We're just going to start with the left side. So f at 2 plus 5 is the same thing as f at 7, which means I'm going to put 7 into the f function. So I would have 7 squared plus 3, which gives me 49 plus 3, which is 52. Then I'm going to come over here to the right side and see if I get the same thing. So this time I'm going to be doing them separately. I'm going to do f at 2, and then I'm going to add to that f at 5. F at 2 means put 2 into the f function, so I'm going to say 2 squared plus 3, which would give me 4 plus 3, or 7. And I'm going to add to that f at 5, which would be 5 into the f function, 5 squared plus 3, which is 25 plus 3, or 28. Then I'm asked to add those two together, and I get 35. Obviously, these are not equal, and therefore we found out that f at 2 plus 5 does not equal f at 2 plus f at 5. So does that equal each other? Not equal. This example 3 shows that in general, f at a plus b does not equal f at a plus f at b. This means that there is no general distributive property. For function notation. I wanted to add a part C here for us because this is one of the things that is on your quizzes and tests in this unit. So let's add a part C. Let's find what the value of f at x plus 2 is. So in this instance, or this example, we're not just putting a number into the f function, we're putting a quantity that has a variable in it, x plus 2. So I'm going to put x plus 2 in parentheses and square it, and then add 3. So I'm putting x plus 2 into the f function. So x plus 2, that quantity squared, I've got to remember that that means x plus 2 times x plus 2, and then don't forget that plus 3. The biggest mistake I usually see here is people try to distribute this and say it's just x squared plus 4, which is not correct because it's the quantity x plus 2 multiplied by x plus 2. And so you have to use FOIL and make sure you distribute, and there's a middle term that you're going to be getting. So when we FOIL, we get x squared plus 2x for the outers, 2x for the inners, and the last term is 4. So I get this quantity from multiplying x plus 2 times x plus 2. I've got to remember that plus 3. And I'm just going to get my like terms together, and I get x squared plus 4x plus 7. Notice again, you've got to make sure when you have a quantity squared that you multiply the quantity times the quantity again and use FOIL. So you should have a middle term. All right, let's go down here to the bottom where we're going to talk about the vertical line test. If you draw any vertical line through the graph of a function, it will intersect the graph at no more than 1 point. So, for instance, if I was to draw a line, and I asked you, is this line a function? You would use the vertical line test. You can use your pencil, and I just put my pencil on the graph, and it only hits the line in one place. No matter where I put it, it passes the vertical line test, so this is a function. And let's draw a picture of a quadratic. Let's do the same thing. I'm going to use my pencil as my vertical line, always passes the vertical line test, only hits the graph in 1 point, so it is also a function. See what happens when I turn my quadratic on its side. And you'll notice that it does not pass the vertical line test because it hits it in 2 places. So this is not a function. Alright, so let's summarize everything that we've looked at in our notes here. It says that there are 3 ways of looking at functions. The very first way that we have is a table. That's where we can put things into, say, an XY chart or table where you might have look like this. And you have x and y values. For each x value, you have only 1 y value. So I could make 2, 3, 7, 9, 15, like that. That could be a function, and it's in table form. You can also think of it as an equation. I could write an equation, or I could graph the points. One other thing I want to say about the table form, which I've given an example of here, table or set of ordered pairs, because a table is a set of ordered pairs. So functions can be as a table or set of ordered pairs. You can write an equation for a function, or you can graph the function. These 3 ways can be united when we think of a function as a set of ordered pairs of the form x, y, which can be graphed in a coordinate plane. That's where I've taken all 3 and put them together. And that's the end of your notes.